This first video is on the mean value theorem for integrals. If you recall what the mean value theorem was for derivatives, you had to have a derivative that was less than 0, derivative that was greater than 0, and by the mean value theorem that would guarantee that your function would cross the x-axis. Well, the mean value theorem for integrals states that the area of a region under a curve is greater than the area of a inscribed rectangle and less than the area of a circumscribed rectangle. So the mean value theorem for integrals states that somewhere in between the inscribed and the circumscribed rectangle, there's a rectangle whose area is precisely equal to the area of the region under the curve. So the mean value theorem for integrals states if f is a continuous function on the closed interval from a to b, then there exists a number c within that closed interval such that the integral from a to b of f of x dx is equal to f of c times b minus a. It's important to note that the mean value theorem doesn't tell you how to find c, it just guarantees existence of at least one number c within that interval. So that's going to help us to find the average value of a function. The value of f of c given in the mean value theorem for integrals is called the average value of f on the interval from a to b. And right here you have a formula to find the average value of a function on an interval. And then we can also rewrite the theorem this way. You can take the 1, multiply it by the integral, which will then send the integral to the top, divided by your b minus a, which essentially is saying the top portion is giving you the area, divided by the bottom portion is giving you your width, times your f of c, which is the value given by the mean value theorem, and that's equal to your average height. So let's go through an example. Find the average value of f of x is equal to 3x squared minus 2x on the interval from 1 to 4. Well, using the average value of a function on an interval formula, we have 1 over b minus a, the integral from a to b of our function times dx. Well, here's a, here's b. So it's essentially 1 over 4 minus 1 from 1 to 4. We're going to integrate 3x squared minus 2x dx. So our outside portion is 1/3. If we integrate the inner one, that's 3x cubed over 3 using power rule minus 2x squared over 2. And we're going to evaluate it from 4 to 1, or 1 to 4. And then that'll give us 1/3. I can simplify this by canceling these out, So I'll have 4 cubed minus 4 to the first power minus 1 cubed minus 1 to the first power. My bad, this should be squared. That'll give us 1/3, 64 minus 16 from the first one, minus 1 minus 1. So 16 minus, or 64 minus 16 will give us 48. And then well, 1 minus 1 is essentially going to give us 0 here, not a 1. So we really have 48 over 3, which is simplified to 16. Example 2 says, find the values of c guaranteed by the mean value theorem for integrals using this same function. If you recall, that mean value theorem for integrals is what we're going to use right here. So essentially we've done all the work already. We're going to take the integral from 1 to 4 of 3x squared minus 2x dx, and we're going to set it equal to f of c times 4 minus 1. So that gives us, we know that this simplifies to 16 because we did it in example 1, equals to f of c, which we don't know yet, times 3. If we divide both sides, this didn't give us, this gave us 16 at the very end, not yet. Evaluating this integral, it would give us 48. Dividing by the 3, it gave us the 16, and that was our f of c. Well, now what we're going to do is we're going to take f of c being equal to 16. We're going to replace c with the x from our function. So it'll be 3c squared minus 2c equal to 16. Bring over the 16 and factor. We'll end up with 3c minus 8 and c plus 2. We set them equal to 0. C will equal to negative 2, and c will equal to 8/3. So based on these two solutions that we have, we're looking on the interval between 1 and 4, so automatically that is going to cancel out this one because it doesn't fall within our interval. So therefore our answer would be c is equal to 8/3. And that is it for the mean value theorem for integrals.